Hello, everyone. Apologies, we're having some difficulties today with our technology, so I will start again. Hello and welcome to today's webinar on the topic of biological strategies for improving farmland yields by utilizing the power of BeCrop technology. I wanted to also extend a special welcome to our BeCrop Advisors. These valued advisors are extension of Biome Makers team with full access to our educational materials, tools, and technology. They're helping farmers across the world save money and recover their soil health by applying the right products in the right places based on the soil needs through the power of technology. We started this free certification about a year ago, and today we have over 800 registered in this program. So if you're interested in becoming an advisor, we do send an email after this webinar with a link, and you can definitely register. It's free of charge. It's easy and basically teaches you everything about soil health and how to use BeCrop technology. So hopefully you'd like to join us and the rest of this community. Before we get started with today's webinar, just wanted to go over a couple of housekeeping items. There's a question pane at the right-hand side of the corner of your screen. Please add your questions throughout the webinar. We have dedicated about 30 minutes at the end for Q&A, and we'll make sure we'll get to all your questions. If we don't, we'll send you an email after the webinar and answer any that we may have not gotten through. All of our webinars are recorded, including this one. A link to the recording will be emailed to you within 24 hours. And you're always welcome to check out the resources section of our website for all the previous webinars that we've done and watch them. And last but not least, we're excited to introduce a new tool called BeCrop Project Planner. This tool has been created to help you plan your BeCrop projects in just minutes. It's a smart calculator, allows you to see the number of samples you need along with the timelines based on your project and you know what you're trying to accomplish with either your own farm or with your growers and your customers. This portal now allows you to generate customized proposals for your clients. It's a great tool that's free, available to our BeCrop advisors. So we'll give you a quick short demo on this as well at the end of the webinar, and we'll follow up with an email again afterwards. So if you want your own private demo or you want to get an account, please let us know and we'd be more than happy to set you up. Now, without further ado, I would like to welcome today's speaker, Meri Mullins. I always just call her Meri, so I decided to add in the middle name here as well. Meri is our technical account lead at Biome Makers. She is supporting growers and ag input manufacturers across the US. Meri is utilizing soil data insights to guide her clients through understanding how management practices influence soil biology. She's an engineer by training and brings a system thinking approach to address agriculture and nature as the complex web that it is. Meri will be presenting a very interesting findings on corn yields using BeCrop technology. If you're planning to also attend EcoAg conference in December, I believe it's early December, be sure to attend Meri's session on December 7th on the topic of the state of soil health. Without further ado, I want to pass this on now to Meri.
Thanks, Sarah. Great introduction. Hello, everybody. Thanks for joining us today for another webinar of Biome Makers. Happy to be here, excited to be here. Like Sarah mentioned, there is question panel, so please feel free to drop any questions in the chat. We're going to have plenty of time at the end here to dive into questions, so don't be shy. We're excited to hear from you, and if we don't get to some of your questions today, we'll definitely follow up. For those of you that are new to Biome Makers, just wanted to again, walk through what we're going to do, what we're going to talk about today relative to the BeCrop technology. We'll do a quick introduction of Biome Makers itself and really just dive into our technology and how we can use it to think about yields for the coming growing season. So again, we'll just do a quick intro of Biome Makers. We'll talk more about our BeCrop technology, how that technology can be used to gain insights on yield and crop performance, as well as go through our project planner, like Sarah mentioned. So if we're trying to look at different things side by side, we'll dive into all of that, look at trials, and then just again touch on our BCA program and all of the different benefits of that. So for those of you that are new to Biome Makers, a lot of folks talk about us and think that we're just a soil lab, but I really like to talk about and think about Biome Makers as a technology company. So we're a global company. We have an amazing team of passionate people like myself that are really geeked out on soil health and creating a more resilient food system. So what we do is look at soil biology and understand the soil biology through the context of functionality. So, with all the different pieces that we've been looking at historically in agriculture, we've largely looked at chemical fertility analysis to understand our soils and performance and nutrient availability, but there's a whole biological piece that we've been missing. So that's where Biome Makers jumps in to provide biological insight along with our chemical insights and create a better understanding for decision making and optimizing farming practices, as well as increasing resilience in the changing climate that we're in and just in our agricultural systems in general. So, that's kind of a little bit about Biome Makers, but we have this technology that we use and it has many use cases, which we'll dive into a little bit today. But the BeCrop technology is really unpacking and unraveling the networks and the functions of the soil biology. So we use DNA sequencing, and that's kind of the lab side of things, right? We do have labs. We have labs all over the country, or all over the world. And the lab is doing the DNA sequencing part and giving us the taxonomic breakdown of the fungi and bacteria in the soil. And what our technology does, and really the bread and butter, is it boils down the functionality of the bacteria and the fungi in the soil. So going from just a list of microbes, which not a lot of folks can do much with, to a comprehensive report and analytics to understand the function of the microbes and how things are actually moving and grooving. And we'll talk about what those functions are and the importance of them and why we should care about biological function when we're talking about yield. So we deliver these really nice user-friendly reports that give actionable insights to growers. And the way I think about it is really empowering agronomic decision-making with biological insights. So, in this conversation, we're talking about how we can utilize this BeCrop technology to make more informed management decisions. Just another use case to touch on, we do a lot of research trials as well. So we'll talk about that a little bit also in comparing where we have high yield and low yield areas and looking at them side by side in more of a research context and an exploration context in our management practices to see why certain things are happening. So again, today specifically, we're going to talk about how we can use our BeCrop technology to improve yields and understand why we might have high yields in some areas and low yields in the other. So again, we're just going to be here talking today about looking at the different categories and the functions of the microbiome. So we're going to look at biodiversity, disease pressure, stress adaptation, hormone production, different soil quality metrics, and nutrient pathways. So before we dive into all of the different functions of the soil microbiome, I wanted to just set the frame for what factors influence yield. Because I think it's really important for us to talk about what things we're trying to understand here when we're trying to diagnose yield deficiencies or reasons why yield might, we might have a lack of yield in certain areas, or if we're really trying to promote yield and increases over our management overall. A couple of things before I dive into this also. So what factors influence yield? There's a lot of them. And also, we want to think about ROI as more holistically as well, right? So if we have a yield gap or a severe yield drop, how can we, maintain yields year after year while maintaining or increasing our ROI overall? So I like to think of things as a whole system. So while today we're talking about yield, I just want everyone to also keep in mind total operation ROI, which by managing different stressors that influence yield and production quality and plant health overall, we may be able to adjust by decreasing input costs and while maintaining yield, right, is an improvement in ROI, increasing resilience overall. So just wanted to mention that as well while we're talking about yield today. ROI, total ROI is a really important way to start thinking about things as well. So let's talk about what influences yield and production and plant health overall. Stress influences yield. Some that we can control and some we can't. So what we really want to understand and dive into is in our system, what stress can we control? What stress can't we control? And then how do we manage and mitigate the stress that we can control so that when there is stress that we can't, it's not impacting our yield? So let me give a couple examples. Moisture and water is obviously a really big issue, right? Nutrient availability, nutrient deficiencies, mineral deficiencies. These are things that cause stress. We can't control precipitation, right? We can control soil moisture with different, residue, cover crops, improving soil organic matter, increasing water infiltration. So while we can't control precipitation, we can work to control water infiltration. Similar with mineral and nutrient availability and deficiencies. There's mineral and nutrient banks in the soil. We also use fertilizer to bring those in because we're hauling products off that are taking the nutrients away from the ground, right? So we have to bring some back in. What type of nutrients we bring influences stress that we can control. Improving biological pathways if we find mineral deficiencies. That is, a stress that we can control, right? If we know that the minerals are there, but they're not showing up in our tissue analysis, why? And that's what we're going to talk about today, is really starting to dive into the why in our particular operation, why we're seeing deficiencies, why that's influencing yield and production and plant health overall, right? So all of these different things we have to think about, and just stress overall is what's influencing yield. And the more days of stress we have, the more that's going to impact our yield and our production. So how do we manage stress? And with looking at all these different factors. So there's a number of them that we can actually look at with the BeCrop technology. So, we go back here to the different things that influence stress, and these are the different biological functions that can help us manage that. So pathogen resistance is a function of soil biology. The biology, there's a small sliver that are bad, the rest of them are good, and they're helping us protect us from the bad stuff. Plant stress adaptation. We need the soil biology to feed us and feed our plants the stress adaptive hormones to help us be tolerant when we can't control precipitation, when we have mineral deficiencies. Nutrient mobilization. So, giving access to the nutrients and the minerals that we have in the soil or that we're applying in our fertilizer, and making sure that we're getting good use efficiencies of that fertilizer, that, those inputs that we are putting down. We want to have maximum efficiencies, and that is a function of soil biology. In addition to hormone production. So obviously we need good hormone production to put on a strong flower, put on a strong fruit on our plants in order to produce that yield. So all of these things are functions of the soil biology, and like we talked about, are influences of yield and production and plant health. So when we kind of break this down into, okay, so we talked about what influences stress, we talked about how the biology is has direct correlation with how we adapt to stress, whether that's through increasing mineral availability or increasing stress tolerance, all a function of soil biology. So what does that look like in terms of what we look at in the BeCrop report and in our technology, right? So we're looking at biological data. So we're understanding the bacteria and the fungi, and we are looking at in the soil microbiome, what things provide stress tolerance, heavy metal remediation, drought tolerance. We look at phytohormone production, we're looking at nutrient pathways, and we're looking at pathogen resistance. So both the pathogens themselves in addition to different biocontrols, so the good bacteria and the good fungi that are there to help protect us from the bad stuff. And then, when you combine that with your actual available nutrients and your micronutrients, you get this full picture of biology and chemistry working with us, excuse me, to create a healthy plant ecosystem, which is ultimately what correlates with yield and production, right? So what we're doing, and just to touch a little bit on, you guys know this, but we're taking the soil, like I mentioned, into biodata and creating these functional reports. We can talk about protocols and stuff like that later, but I really wanted to jump into a case study. So we have a grower who's trying to diagnose why there are yield differences across his fields. With the same management practices, they suspect that it might be some K deficiency, and they also suspect that there might be issues in potassium uptake and phosphorus uptake, excuse me, and they've been applying this over the years. So what's the action? How do we diagnose why we keep applying nutrients, but we're not getting good use of them and we're still struggling with yield? So we're going to run some BeCrop tests with our fertility analysis. So we're going to look at the biology and the chemistry, because we've been looking at just the chemistry for the last few years, and it's not really giving us the answers that we're looking for. So we're going to look at the biology portion as well, and we're going to understand the nutrients and the biological activity that may be contributing to try to see if we can get to some answers. So here's getting to the why. Now, when we take, so let me, when we ran this analysis, right, what we did was we went and sampled each one of these rows is one field. Okay, so we went and sampled multiple fields, multiple areas, and categorized where we had low yield and where we had high yield. Now we can start to differentiate what the differences are in the soil and start to understand why we might be seeing some of these things. And then we can go from there to create action, right, to increase yield and level out the playing field. So in all of the areas that we saw low yield compared to high yield, let's look at some of the trends. So there's a lot of yellow over here. Now let's talk about what that means for those of you who don't know. When we look at our report, so this would be, the mechanisms in one report. Again, these are multiple fields we're looking at together here and what we call a heat map. We're looking at ranges from very low to very high. So amongst our entire, database of, tens of thousands, hundreds of thousands of samples, this, very low represents that particular soil had very low pathways for nitrogen relative to our entire database. And then we can look at them side by side and compare the actual percent change. And you can get to that in your portal to look at the actual numbers here, but we're just going to look at the color gradient for right now. So the overall trends here, we see, relatively low, very low nitrogen pathways across the board. We're seeing a lot of low phosphorus and potassium pathways here across the board. Overall, just, if you look at this compared to this, in the areas where we had low yield, every one of those fields has at least low nitrogen or low phosphorus, potassium. At least one of those major pathways is low, or more of them, right, in some of the areas. And then when we look at the trends over here in the high yielding areas, we see that largely we have better nitrogen cycling, better phosphorus, and better potassium cycling. So again, just to break down what this means and what this tells us, is we're looking at the bacteria and the fungal communities that are responsible for availability of these nutrients. When we have low availability, low biological activity, or low biological pathways for those nutrients, we might see low, when we look at our tissue analysis, we may see that that's also low, but we don't understand why, because in our fertility analysis, it showed that we had plenty. Or we know that we applied plenty of nitrogen, potassium, or phosphorus early on in the season, so we know that it should be there, yet we're still having low yields and not seeing in our tissue analysis, for example, and now we can start to understand why that's happening. So what do we do with the why once we understand that? Okay, so in all of these low yielding fields that I can compare side by side in your data portal, we need to improve nitrogen, phosphorus, and potassium cycling. That's really important for crop health, right? And we know that in our high yielding areas, that's what's working. So, why might that be happening? This is another insight that we can dive into in the portal, right? We can actually look at some of the potassium and phosphorus metrics and actual bacteria that are contributing to those things. So that might help us with some of our action items as well. So, in this scenario, we're going to dive into more of the data here, but in this scenario, what action could we make? We want to improve phosphorus and potassium pathways. We could do that with a biostimulant by activating more biological activity. We could work on improving and increasing, actually re-inoculating the soil with particular bacteria that help mobilize those nutrients. Nitrogen was another one of the deficiencies in this example. So this is how we go from the why to the action is, we need to understand the why first, and there's going to be many opportunities to improve and address that question, right? But adding more nitrogen, phosphorus, potassium when our pathways look like this isn't going to help us. What we need is to work on the soil biology piece, right? Unless we get that activated, more nutrients aren't going to solve our problem. So we need to do it by tending to the biology. This is just one way that you could address these specific issues. There are many ways, and this is where our BCA program, and we really want to build this network of our BCAs, because we want, ultimately the crop advisor, the consultant, the PCA, the CCA, the agronomist, they're making this decision, right? We need you guys to make that decision. So understanding how to interpret the reports and how to get to some of these things and understand the why is what we help you do. Creating the action for how we address those issues is really what we want to empower you guys with. So let's just continue with this example and look at some of the other things that may be impacting the stress or the yield, excuse me. So again, we talked about the function of the soil biology and all of the different things that might influence yield. Well, nutrient pathways, like we looked at, were one example. Another example is the hormone production and stress adaptation. So in our reports, we're also looking at the auxin production, cytokinin, gibberellin, and different metabolites and stress hormones as well. So if we, in this scenario, we had low biological pathways for some of our major nutrients, and then we also have low biological activity to support growth hormones as well as stress adaptation. So there's not always just one thing that's influencing yield, right? We know this, there's many things. So we need to think about what is kind of the low-hanging fruit that we can address to start to improve soil biology, soil resilience, and production and yield ultimately, but addressing the root cause of that, right? And that can take time, but we need to understand the root cause to start addressing those things. So again, in this particular case study that we're looking at with corn, where we had yield differences, we started to look at, okay, what can we do to improve these things? So from 2020 to 2021, now we're getting into how we can track changes over time in your portal. And these, again, are heat maps from the portal. And you can look at how we improved some of these cytokinin, gibberellin growth hormones into 2020 to 2021 and actually show the track changes. And hopefully what that delivers is increased production and overall plant health and resilience over time. Again, we looked at the nutrient pathways. Here includes some of the micronutrients. And then we also have, so this is the heat map that kind of lets you compare two fields side by side or 2 years side by side in these heat map tools. And then you can also get into our raw rank box, which actually breaks down and looks at the numbers, like I mentioned, and how things are changing over time. So from 2020 to 2021, we had a 12% increase in iron assimilation, which iron is a really critical plant micronutrient. Same for humans, right? We need it for our immune system and stress adaptation, stress tolerance, and we improved that biological pathway from 1 year to the next. So these are just, again, tools to look at how exactly things are changing, what kind of improvements we're making with the programs that we're implementing. From 2020 to 2021, so this was probably in one of the high yielding areas, right? We had a decrease, and that happens sometimes. So let's, we want to dive into why that might have happened and address it right away in 1 year, rather than that continuing on for years and years. So there was a decrease in our, in these couple fields. In our nitrogen, we had increases in potassium solubilization, but some decreases in nitrogen. So why did that happen? And we can dive into that and start to address the root cause, because we know if we're here, applying more nitrogen isn't really going to be our solution. It's going to be improving that biological pathway so we get efficient uses of the nitrogen that we're applying today. So I guess I'll stop there and see if there's any questions before we go into the portal. Maybe we can do a quick Q&A on the pathways. Let me see if there's any questions so far. Anything, Ava, Sarah, that we want to dive into, or we want to go into how everyone can learn more about these things and look at the
well, we have a couple of questions. Maybe we just answer maybe 2 at this time, and then we'll go into the portal and then get back to the question panel and see how many we can get to. The question comes in, does BeCrop technology only used for agriculture, or can it be used for florists? And then the same person had asked, can we use data from BeCrop technology together with soil analysis and with Brix levels of leaves to combat pest attacks in regenerative agriculture?
Okay, so a couple questions. The first question, can this be used with flower production as well? Yeah, totally. If it's, if you're growing something in soil, you can definitely, it has a microbiome, so relevant for flower growers as well. It's also part of agriculture. It's just not food production, which is totally fine. So yes, to that question, we can certainly look at flower production. The second question, can you repeat that, Sarah?
Sure. Can we use data from BeCrop technology together with soil analysis and with the Brix level of leaves? I'm not sure, to combat pest attacks in regenerative agriculture.
Yeah, so I guess, let's see if my video will work for a minute. So using your BeCrop test with your fertility and your soil analysis in combination with tissue analysis, sap analysis, Brex, all of those things can be correlated and looked at together 100%. And it can be outside of, I mean, a lot of conventional agriculture is doing this as well. It doesn't have to be, regenerative. So I would encourage all growers should be looking at your biology, your chemistry, and your tissue analysis, or your Brex is really how things are going. Your biology is kind of why things are going that way, and your chemical fertility analysis is like what you have available to make things move, right? So I would absolutely encourage looking at all of them together, laying them side by side. We have a BeCrop Plus report that actually puts your biology and your fertility in the same report side by side, so you can look at, well, I've got all of my nitrogen, phosphorus, potassium available, but I don't have the nutrient pathways, and that must be why I'm seeing a deficiency in my soil or my tissue analysis, or my Brex is low, and I can start to address the why. So Brex relative to insect pressure as well, it's all tied together, but your soil biology and the microbial rigor and vigor of your soil biology is directly related to your Brex score. So I encourage you, understanding both is definitely valuable. As far as the long answer, we could go down a whole rabbit hole on that one, but great questions. Any other questions that we want to answer before we move on?
We have a number of questions coming in, but I'm thinking if you don't mind, Meri, giving access to Ava to present the portal quickly.
Oh, sure. Yeah,
Then we can do a quick demo and then get back into the questions.
cool. Let me frame that up for Ava too really quick, and she'll probably do more of this, but so when we look at, let's see, let me just, it's not gonna let me go back, but when we looked at that big graph, right, and when we look at these things, when we're looking at things side by side, that's something that we wanna set up and we wanna plan, right? We wanna plan even if it's just like agronomy, it doesn't have to be like this full research academic thing. It can be, we love doing that too, but that big graph where we showed the reports across all of the fields, we can plan that out, right, as agronomists, so that we can help our growers and generate a nice trial design that we can hand to our growers and make sure that we're pulling samples in the right location at the right time, based on what our goals are, right? So in that first example I gave, where we looked at all of the different boxes side by side, that was a trial that we planned out, and I'm going to pass it over to Ava to walk through the new tools that we have available for BCAs to plan trials and plan work based on your what your goals are. So pass it over to Ava to run through that.
Hi everyone, thank you so much, Meri and Sarah. I'm unable to share video today due to some network issues. Hopefully you can hear me okay. So as Meri mentioned, and I'm going to sort of walk you through this new BeCrop project planner portal that we have created for BCAs to plan projects. It makes it really easy to know, first of all, how many samples you will need. It auto calculates a lot of that for you, and it will also give you a estimated cost for the project and give you some tools to edit, and it will also generate proposals for you that you can easily download and share with your growers. So here's the dashboard. So when you log in, and we will have to create this account for you, and you'll need to ask one of our team members to set you up with this. So once you do have an account and you log in, this is what you will see. It's your dashboard where you will have the proposals that you have created in the past that you can download, edit, or make changes to the economic terms. So let's say we want to add or create a new proposal and plan a new project. You'd want to click on this plus sign on the left corner in this toolbar, and this will give you a few options. You can design trials, you can do a BeCrop rate project, or you can do a BeCrop test that can be focused on yield, disease, or management as well. So let's just start with a trial over here. And depending on your objective of your project and why you are looking to do a trial, there are a few ways, basically levels of complexity that will help you answer from simple to more complex to the most complex questions. So the most simple one will basically tell you what your product or management practice, whatever it is, that input that you are using does in that one specific location. And this, you can scale that up to get an answer to what does your product do, not necessarily in that one location, but maybe with more confidence, attributing the changes to the actual input, not the location itself. Or you can basically look at a most complex answer of where should you recommend your product and what are the factors that affect the performance of the product. So let's do a medium size, for example, here. Some of these are for employees, so you may not, Biome Makers employees, so you may not see all of these over here. So you can, but for a company, for example, we are going to do Biome Makers, project leader, email. You can basically write that. Here. And you can create a proposal name, although this will generate that for you. If you want to write your name, for example, consultant, or let's say we're going to call you the best consultant over here as a sales. For example, you can add users here on the left side if wants you to create an account, and that will pop up for you there. So once you have that, you can write the proposal name, or it will auto-populate for you. You can choose the sample type. Let's say in this case we have corn. You can choose whether or not you want to add a physiochemical report or an additional analysis package that is for bigger projects, that gives you even more insights into the indexes and taxonomic information. And here you can add locations. For example, let's say we have area 1 over here, area 2, area 3. And let's say that we have a product, let's say Biological 101. And here you will basically start the date. This is roughly when you'd like to start your trial. Let's say you want to start it 15th of March. Replicas here, this is very important. So replicas, we recommend a minimum of 3. This will basically eliminate any variations due to sampling. So if you have more replicas, that will basically generate an average of all of your metrics that can be used, and it creates a buffer for variations in the point that you took samples in on your farm, and really increases the confidence and the accuracy of your results. And this, with just a few pieces of information that we entered here, we have a project that has been planned out here. So T0 is before applying any input or any product. T1 is after, so 15 days after application, or you can here edit that to, let's say, 30 days. And if you want to add an additional time point, you can do that here. So for example, if I put 90 here, that will be 90 days after this time 0. So I can add that here, and that will basically just create that for you. And you can see here the total number of samples that you'll need. You can select your currency, and it will give you the retail price. You can submit this, and it will basically go into that dashboard where you have all of the other projects as well. So let's say we want to make adjustments to a proposal. We have this economic terms over here. You can click on that. And if you want to add a consulting fee, you can do that here. So you can do that either in percentage or currency, whichever currency you selected when creating the proposal. Let's say you want to add a 20% consulting fee. You can do that here. You can add any payment terms that may apply, and that will basically just update the total price of any project that you have in your dashboard. You can submit that, and it will 100% upfront, for example, for the payment terms. Submit that, and that will give you that. So you can download this proposal. It will, and once it's been accepted, you can click on this thumbs up. That means that it's been accepted by your client, or you can give it a thumbs down if it was rejected, and try again. So not to get into too much of that, but just wanted to also show you BeCrop Rate and BeCrop Test. You can sort of do similar setup over here. Say Biome Makers. And we wanted to, for example, select a couple of different areas to do a BeCrop Rate on. And if you want to learn more about BeCrop Rate, do visit our website. We can give you basically an assessment of the impact of management practices on soil health. So if you want to make that assessment, this BeCrop rate will allow you to do that. So this is the example that I want to share with you, is the auto calculation of the number of samples in this case. So here we have, let's say you want to you have high yield in one area, you have low yield in one area, and medium yield in another. If you have previous BeCrop ratings in any of these areas, you can add those here as well in this management piece. If you don't, you can leave that blank. You can increase the resolution if you do twice the number of samples. And here, as you can see, area 1, we based on the number of acres that we inputted, it calculated the number of samples necessary to create that BeCrop rating. And another important feature is that you can add additional analyses using the same samples. If you click here below, for example, now I am doing a yield study as well as a BeCrop rate study. So you can use the same samples and it will have an additional cost, but it will not be the same as in analyzing the different samples, and you won't have to collect new samples for that additional analysis. So that's very handy there if you want to kill a few birds with one stone. And again, you can change the resolutions here if you'd like. And then you will get a summary of your project here. Area 1, 50 acres, the number of samples that were calculated. Again, you have the total number of samples and the estimated price that has been created here, and you can just go ahead and create that proposal. And there you have it. So we can do the same thing with the BeCrop test, very similar features. I won't get into that too much, but basically once you have this sandbox account, or if you're set up with us as a BCA, you can use these features to create any proposals for any projects that you are planning with BeCrop. And a couple other features here to quickly highlight: products that you are using or that you are studying, you can add them here. Locations, you can add and edit as well. The parcels that you have and the numbers of acres that they have and the crops that you are growing in them, as well as any users on your account. So that's basically in a nutshell the demo that I wanted to give you for this BeCrop project planner. Do reach out to us if you have any questions about it, and we can get you set up. Wanted to quickly highlight, I put in the chat a link to the BeCrop Advisors page. Here you can basically learn more about the program, and if you wanted to sign up, you just scroll all the way down here and fill out this form, and that should automatically enroll you in the program and give you access. And once you're graduated from the program, it takes about 2 hours to complete the program. We made sure to make it very time efficient for you. Then you can reach out and we can set you up with the BeCrop project planner. Or if you already are familiar with BeCrop technology and want to get straight to the BeCrop project planner use, you can also reach out to one of our team members and we can set you up. Thank you so much, and I'm going to hand it back to you, Sarah and Meri.
Thank you so much, Ava. Appreciate you providing an overview of the portal. More information will definitely be sent to you after this webinar. So if you're interested in getting in touch with us, there'll be contact information there as well for you. Okay, well, let's jump back into the questions, and I'm sure many of you are still waiting to hear answers to those. We have a question here. Other than the absence of specific microorganisms, can you determine why those particular organisms are or are not present?
That is a good question. So our test isn't analyzing why something's not there. We can't tell why that organism died away or isn't being brought to the table because it's not being fed. There's many different factors that can go into why certain biological communities are missing. We're really diagnosing what's going on today and how things are changing over time. So what we can do is just, I guess, encourage, okay, so if we know that there's this community missing, we can start to ask ourselves why, right? By looking at what factors influence the soil microbiome? There are many factors, right? We looked at that. There is, the products that we use influence the soil microbiome. Tillage influences soil microbiome. Whether or not we cover crop and keep the ground covered through fallow or through our off season influences the microbiome. Heat, water, all of these things influence the microbiome. So there's a number of factors that could have gotten us to where we are today. The first step is understanding like where we are today, right? And how we're going to get to the next stage. So we're just looking at who is there today and what they're doing, so that we can start asking ourselves why things might be there and addressing how we can get them back. So I think that's a great role, I guess I'll just add, of the BCAs and our agronomists and consultants to help us as growers ask those hard questions of, well, why are we here today? What got us here?
Amazing. Thank you for that answer. Another question. I'm assuming the soil analysis is done as a composite sample, which is GPS marked, so that you are taking samples from the same spot the following year?
Yes, your assumption is correct. We are taking composite samples. So I know there's another question on the sampling protocol too, so I can just go over that really, really quick. Our samples are taken very similar to how chemical fertility analysis is taken. We're running a 6-inch core, roughly, and collecting about 10 of those in an area that we drop a GPS pin in the middle of, and then make a bucket of soil from that, those 10 cores at 6 inches, mix it all together, homogenize it, and then pull our chemical fertility analysis and our BeCrop at the same time. The only big difference there is that we need our sample within 3 to 5 days. So best to overnight it to us straight from the field. If you can't, or you're collecting samples over multiple days, throw it in the freezer and then ship it to us on ice. We are looking at biology, so we definitely want to preserve soil conditions. So plastic bags or tubes are required. We don't want it to dry out, and keeping it at a stable temperature until we can analyze it.
Great, thank you for that, Meri. Next question. Large fields aren't uniform. How even is microbiome? How many soil samples per hectare we need to analyze to get meaningful results?
Great question. So what we recommend is zone sampling. Zone sampling based on how, different variability in the soil. So if you have a large field that is has 3 different soil types and you notice that they're drastically different in the performance or if the soil type, you notice the soil conditions different, we recommend zone sampling. So we don't go as far as grid sampling. I don't think that's cost effective or makes a ton of sense biologically, but zones is the way to go. So that's how we account for soil variability and conditions. So you're looking at soil type, maybe elevation, if there's any flooding in certain areas. So however you categorize zones in your practice is how we would recommend sampling. Does that answer the question? Did I get to all of it?
Yeah, I think so.
Yeah, zone sampling. So you can account for the variability in the microbiome and soil types.
But if we were to tell them how many samples they will need per hectare.
Oh, right.
So how do we?
Yeah, so again, your question kind of answers that, is there's not a set sample volume per hectare. That's why in the portal that Abba showed, you can change the resolution a little. You have to use some of your intelligence and know your knowledge of that area to determine how many zones you want to sample, and we would recommend 1 composite per zone. So if you have, it's not necessarily by hectare. If you have a 100-acre field with 3 zones, then you'd want to pull at least 3 samples or have those 3 zones. If you're running a replicated trial, then you may increase the resolution and have 3 samples in each zone, so you'd have a total of 9 samples. So that's why that tool is there, because it really, the number of samples that you're taking really depends on what your goals are and the variability that you're presented with in the field. So it's not necessarily done on a per hectare basis, it's done more on a per zone basis. So we do 1 composite sample per zone, increase from there if you're trying to get statistical relevance and replication.
Great, thank you for that. Another question has come in, and this is an interesting one. Do you make cover crop recommendations to tap into the deficient nutrients?
Good question. We do not make cover crop recommendations. Green cover seed is one of our, is one of them out there that has a great cover crop calculator online if you're interested in addressing specific issues in your operation. So shout out to them. They have a great calculator online. What we can help you do is diagnose what the issues are so that when you go to a cover crop company, you can say, I need to address nitrogen mobilization, phosphorus, potassium mobilization, and can you help me build a blend that'll address those issues that I have? So it's good to know the issues that you have before going to build that cover crop blend with the experts on that side of things.
Okay.
But yeah, I don't know. Do we have a drop? We can drop someone can drop the green cover soil calculator in there, or cover crop calculator. I can drop it in. Was there any other questions?
Where are you located and where are your labs located? Good question.
Where are we and where are we not?
Where are we located and where are our labs located?
Gotcha. So our company is based in West Sacramento, which is also where our lab is in California. We also have a lab coming online with Regen Ag Labs in Nebraska in April. We have another lab in Florida, and then we have labs all over the world. So France, Spain, Brazil, ? And yeah, so we're a global company. We've got labs all over. We have headquarters in California and then in Spain.
Amazing. We may have time for one more question. And then again, if we don't get to all of your questions, we'll make sure that we answer them right after this webinar. Do your reports also look at the impact of access nutrients?
Yes, I'm going to assume like access and availability to nutrients. Yeah, so our functionality or I don't know if you can give me screen sharing power back, but I just show one of our reports. We look at the biological potential and to move nutrients, right? So we're looking at the nutrient mobilization based on biological activity and the organisms that are present. So here's a really great example. Your fertility analysis, whether you run a Malik 3, whatever extraction method you're running, is supposed to deliver some available nutrient metric. What that metric tells you on your chemical fertility analysis, they're extracting those nutrients using an acid that's supposed to mimic what's in the soil, based with the plants and the biology. If your plants aren't producing enough and you don't have the active biology, what it tells you on your chemical fertility analysis isn't available. It's dependent on having the right conditions in the soil to extract those nutrients and make them available. That's what they're doing in the lab. They're extracting the nutrients using a chemical process to mimic what should happen in the soil to tell you what's potentially available. So your chemical fertility analysis, potential available nutrients, not actually available. What's actually available depends on what nutrient pathways are there in the soil to digest those nutrients and make them available. So I hope that answers your question. We're not, we're measuring the biological potential to unlock nutrients.
Maybe one more, if that's okay. Can you elaborate a bit more on how you get from the DNA sequences to functionality?
I can elaborate a little bit more, but that's our special sauce. So what we're doing is using the DNA sequencing, right, ITS and 16S to make a list of bacteria and fungi. From that, we plug that into our system. That is an artificial intelligence that is constantly learning. That is our proprietary database that takes all of those microbes, understands how they all work together, and then delivers this beautiful functionality report that tells us, what exactly is going on. So the database is constantly learning. The more microbes that we understand, the more networks. It's built off academic research. You can find a ton about that on our website through all of our methodologies that we use to derive some of those things. So I encourage you to explore some more of the literature. It's out there, but that's a little bit of a high level of how we go from DNA sequencing to our amazing functionality reports.
Great. Well, I think we're coming to the end of the webinar, Meri. I want to thank you for your time, for sharing your knowledge with us. Meri is very active on LinkedIn. If you guys are interested in learning more about soil biology in general, follow her. She shares a lot of great content. She's amazing at being obviously active and sharing her great knowledge with the industry. So follow her on LinkedIn. We'll also share a link to her profile in the follow-up email. Reach out to Meri, reach out to any of us. I apologize, I never got to introduce myself. My name is Sarah Bassiri. I head up global marketing for Biome Makers, and I have the pleasure of being here on camera with you today. Thank you for joining us. If you have any questions, comments, or thoughts, please share it with us. If you want us to organize any webinars that you have an interest in, please also share that with us as well, and we'll do our best to organize it in the near future. Thank you, and we all hope you have a wonderful rest of your day. Bye for now.
Thank you, everybody.